speak to the mic, right? Okay. Okay, wonderful. Well, hello. Thank you all for coming. Let me make sure I don't look ridiculous. I'm okay. On the audience. So some of you guys I've seen before, some of you are new. Regardless, welcome. Thank you for coming to the Sign Protocol workshop. Who here actually flew from a different continent? Where from? Which continent? North America? North America? Oh, nice. Well, thanks for flying for like 17 hours and just to be in my workshop. But obviously, I know you guys are here because you're after the money, which is fine. I'm offering. Just don't spend that money tonight, okay? So we're Sign Protocol, okay? So we have 30 minutes. I can mess around and talk a little bit of random stuff. So those of you who are just here for the money, I can give you a little bit of introduction. I like the honesty. You know, if you're here just for the money, then you know it's good. It's good. You know, it's like if you are a gold digger, then just make it clear. You know, so which is fine. You know, that's valid. So Sign Protocol, we are a hello Megan and Zoe. Thanks for supporting me. Sorry, I refuse to wear your merch. Okay, our merch. Okay. Okay, so Sign Protocol is an omni-chain attestation protocol, and exactly what that means, I'll get into it later. But you know, before I get into the nitty-gritty, I want to talk about some of the grand visions of Sign. So at Sign Protocol, we envision a future where all ownership, consent, and identity will be registered and verified in one place, which is a decentralized and trust-neutral on-chain repository. So fundamentally, our vision is to encourage data reusability, basically. So right now, you know, on-chain, there's a lot, especially, you know, in a place where it's stored valuable. For example, you know, before the introduction of signing with Google or whatever, if you had like 10 social media accounts or 10 accounts for 10 different back when web forums was still a thing when I was in middle school, okay? Which is not that long ago. A new username and password to establish a new identity, right? And that's really wasteful because you're just one person, you're the same person, right? And when we moved when Google sign-in and whatnot, you know, those OAuth solutions came along, then you're able to kind of the graphic identity, and that's like the new identity. And you know, for Sign Protocol, what we do is we try to facilitate an on-chain data sharing repository where the data that's being stored on-chain hopefully is meaningful, and we force, well, to the extent that we can. It's like forcing an NFT royalty. It doesn't really work because you can just solely say, oh, I sold this for 0 ETH and not pay anything. But to reuse data, right? To make other people, to tell other people how to interpret your data correctly, so that you know they can make use of it, obviously. And there are more ways to just there's a lot of, you know, tricks I can play to monetize or share your data, which we'll get into later if we have time. Now I totally clickbaited everyone into this workshop because, but it's make attestations gated again. Now, what do I exactly mean by that? What I mean is like a feature that we call schema hooks, and we'll get into it. So today, if you were with us during the San Francisco hackathon about a month ago, then you'll remember my diversity hire white person, Jordan. I'm sorry. He was here. That explained. So no one likes that joke. Okay. He explained the front-end SDK, and we kind of walk through that. So today, again, Sign Protocol, we're the on-chain attestation framework. So to make attestations or to store data on-chain for others to use, it's really, really simple. So just 3 steps, right? The first step is to create a schema. The second step, so the schema basically tells other people how to interpret your data. It's like a JSON thing where it's like key value. The key is the key in your data, the value, right? We can't really enforce that because Solidity doesn't do like JSON parsing. But if you adhere to the rules, you've got, right? And then the third step, after you made attestations, you can basically, other people can actually query. Now, I took this screenshot from our front-end SDK, a list of attestations based on various filters, okay, which we'll get into later. I'm not going to go over too much of the front-end stuff. Today, I want to get more into the Solidity stuff, which I'm good at because I'm actually terrible at doing front-end. Now, this is just a diagram. Now, you don't have to take notes. Don't panic on taking notes because in detail, okay? So I'm not going to zoom in too much here, but basically this is an overview of how the entire system is structured and works. I'll kind of skip over the white user on the left side. So first, and right now we're only looking at the on-chain schema. So as you can see from, we actually support two different types of attestations. One is an attestation on the traditional blockchain, which is like EVM or Starknet or Telegram or something. The second one through the API is actually stored on Arweave, and we actually index it. Now, so it's a blockchain that's optimized for data storage, which makes it quite cheap to store data. And the reason why we provided that is basically to make it so that if your attestation is quite big and it's financially not feasible to be stored on chain, we also give you a way to store your data. And also on the I kind of want to talk about this. So on a conceptual level, if your data, if you don't need other smart contracts to read your data, then you don't really have to put it onto like an EVM blockchain or something. Because like if you just want your attestations to be read by humans, and if you just want a guarantee of like smart contracts, humans can actually access the real internet, right? So that's why we provide an API for you to store things on Arweave. And we're actually going to roll out, we didn't make it for this hackathon, but within the month, we'll roll out a up, and you can basically store data into Arweave through us for, it's extremely cheap. It's something like 10 cents per gigabyte or something. I forgot, but it's like really cheap, right? But today we're just going to look at the left part, okay? So, of the hierarchy between the schema and the attestation. So, the schema actually is like this. Now, this entire thing looks like some kind of like Intel presentation of their CPUs. But the schema C contains attestation 1 and attestation 2. So attestations, every single attestation, they must belong to some schema, right? To a single schema. You can't have an attestation that belongs to two of them, right? Now, what is this? So this is the schema hook contract that I've been talking about, and we're going to get into deeper into today, right? So as a schema creator, you can define an external smart contract as the schema hook contract. The data will be, the request or the call data, whatever, like this thing will be routed through the external hook contract so that that hook contract has a chance to inspect the data or do whatever, right? Because it's a smart contract. But the bottom line is, if the code reverts in the hook contract, the attest or the revoke function call will also be reverted. So you can basically use it as a way to gatekeep, for example, who can make attestations. ZK proof in order for an attestation to be written into the schema. So everything in the schema is basically hard gated by ZK proofs, right? So something like that. So this is why this clickbait title is called "Make Attestations Gated Again," because that's what we're going to talk about. I hope I don't look stupid leaning forward like this. Okay, so very briefly, right? I'm still going to cover it, but just really, really briefly. So FE stands for front end. So this is the installation and setup for our front end SDK, which you can use, but it's just not the focus of the workshop today. So the front end SDK is mainly used to interact with either to query attestations and schemas from SignScan, or it's also used to submit attestations using the Sign Protocol API onto Arweave. But it's not the focus of this workshop, so I just have this quick slide, which you don't have to take pictures of. Don't worry, I'm going to have a QR code that links to a slide later. And to make it even better, I'm such a nice teacher, right? There's even the SDK walkthrough from the San Francisco hackathon. It's a YouTube video that the ETHGlobal folks recorded. So don't panic, and you don't even have to scan this QR code right now because later you'll have the QR code for the whole slide. Okay. So I'll skip through this real quickly. So today what we're going to talk about mainly is the Solidity SDK instead, right? So to install it is quite straightforward. You just npm install. Or who even uses npm nowadays? Everyone uses bun, right? That's like the trendy thing. And then there are 2 imports that are important. The first one is the sign protocol interface present on each EVM chain. Then that's how you do it. So with that, you can call the attest function. You can revoke. You can create a schema programmatically. You can, very rare. And the second one that's quite important, which is like the highlight of today, is the smart contract, the sign protocol hook interface, right? And this is basically how you're able to implement a schema hook, create your own schema hook. Okay, so I'll get into that. So a schema hook, right? A schema hook, it's nothing fancy. It's literally just another smart contract that will be called. If you set it as a schema hook of a certain schema, then this contract will just be called whenever someone attests or revokes, right? And we'll go over the interface in a bit after the slides, right? And we have like 4 different examples on our GitHub. So this is like a common pattern, admin contract that dictates who can call your hook, because if your hook contract actually interacts with some other, like let's say you're using it as like a webhook to call some other service, then you don't want anyone to just be able to randomly trigger it, right? You only want it to be triggered when someone attests something. So the caller, and in that case, the caller will be, I have this ownable thing. So what you can do is you can set the sign protocol instance, right, in the admin contract, and in the hook contract, you can check if the caller is actually the sign protocol instance, and if it's not, then you can revert and say that, well, I can't just have random people calling my hook, okay? And afterwards, you implement the actual thing, right? Which I'll show later. Function interfaces for function prototypes, but it's really just 2. It's just like there are 2 variants called did receive attestation, and you notice that it's actually payable. So you can even charge a fee for your attestations. So you can kind of, do a lot of interesting things. And the other variant is basically charging a fee via an ERC20. So that's why the interface is kind of different. But the point is, right, you can charge a fee and you get access to the attester, the schema ID, the attestation ID, and any extra data. So the extra data will actually not be saved anywhere. It will be discarded after this entire attest or whatever function call. So that makes it really convenient. So if you have some really large data that you want to use for verification, cough, cough, maybe something like a ZK, verification data, right? You can pass it through the extra data because you don't have to save it, right? If your logic, if your hook logic verifies it, and if it's correct, then it's like we don't really have to store it. We just have to verify it and then throw it away after 2 weeks. It's the same logic here, okay? And also the message.sender here. So on line 12, you can see that I'm casting message.sender into the sign protocol interface. That's if you get access to the sign protocol smart contract, but then you'll just get access to, like, you can get the attestation, get the schema, such as what I did here, get attestation, and inside, and you have the schema ID, so you can also get the schema this way, right? So you can get all the information about the incoming attestation this way, right? And then you can do like your own logic, you can check data, you can do whatever, right? And I just said a very Canadian about. Okay, I'm sorry. So utilizing extra data. So this is also a part of the one of the examples that we have in our example repository, which you will see in a bit. Okay, so this is a ZK hook, hook contract, right? Basically, on line 13, extra data, and on line 16, we are actually verifying it. And if it's false, then we just revert, right? And that function, verify proof, it's not showing in the screenshot, but it's somewhere. Just know that it's somewhere, and then it returns false if it returns false if the proof is invalid, right? So this is how you can save space, but also utilize the ZK stuff if you're into it. Yeah, using Circon, which I don't know how to do. So QR code for the full documentation. Okay, look, I'm so, this is, have you seen another workshop that does this? I'm sorry. Okay, so this is the full documentation. We have, I just made an issue tracker repository. So if you have any questions or you found a bug, you have a general question, you don't have to wait for like 20 minutes in line or something at a booth or whatever. Submit an issue in this repository. I have 2 issue templates so that we can work async, right? Because obviously I'm not going to be here at 12 a.m. Unlike you, right? I'll try to be here for as much as I can. But if I'm not here, right, and my colleague Jordan, he's in the US, so we basically have full time zone coverage, okay? If you have any questions, general questions, bug reports, your code's not working, submit an issue, and that also makes it a lot easier for me when you come to the booth and debug, because then you don't have to slide deck QR code. Look at that, right? So you can get everything, okay? Everything in this slide just from this QR code, okay? So that was a slide deck presentation. Let's quickly get into the code part, okay, which is the interesting part. And I'll put this back up after we go through the code for Q&A. In our documentation, you'll have basically code examples of everything, but I've already opened it in my VS Code. We have 4 examples. The first one is a good example for how to make an attestation using insolidity. Okay. Now this is called actually met in real life. It's basically where it's just like met in real life, but I can claim that I met Kamala Harris. Laughing Kamala. An attestation will only be made if the other party also confirms that they've met you. Okay. So this is a more legit version of met in real life. This is really simple logic here. Basically, if a schema utilizes this hook, then basically in the whitelist manager, you can whitelist attesters. And when people come and attest to contract interface, there's did receive attestation with the payable, okay? And did receive attestation without payable, but then you have a fee, ERC20 fee token and fee amount, so you can charge fees that way. Right? And it's the same thing for revocation. So you can also get notified or verify stuff when people try to like revoke stuff. Okay. In this case, it literally just checks if someone's in the whitelist or not. Okay. This one, data attester. Okay. I actually forgot what this one does. Let me actually remind myself. Okay, I forgot what this one does. Let's give. A ZK circuit, Circom, okay? I took this from somewhere on the internet, from here, okay? I actually am not very good at writing Circom. But this is an interesting ZK circuit. What it does is that you can prove to someone that the original data that resulted in the hash without showing them the original data. So that's pretty cool, right? So this circuit works, okay? And we actually have, if you scan the QR code, and go to our docs website, we actually have a full walkthrough of how this thing works. But basically, this circuit will generate, and I have like a separate repository just dedicated to the circuit and the setup and the input and outputs. You can write any of this, obviously, you can't hand do it. But this is a generated verify circuit, which has a function called verify proof. It's the one that you kind of briefly saw in the presentation, right? And returns a Boolean true or false if it proves correct or not. And we import it into a ZK hook, okay? And when we're attesting something, basically this schema could be a circuit, maybe, something like that. It's not very meaningful, but it's just a demonstration of how you can incorporate the use of zero knowledge proofs into sign protocol schema hooks, okay? And obviously, feel free to come and find me at the booth, or more efficiently, probably create an issue on that GitHub repository. Okay, let me just ask one question: who's here just for the money and has no? Yeah. How do you think we got this 30-minute time window? I'm just kidding. Okay, question. No, no, we're different. Oh, yes. Sorry. So the question is, does Sign rely on EAS? No, we're two separate products. We're totally independent. We are kind of our own ecosystem. Yeah, and we're present on basically all the EVMs that you need. If it's not up there, the Telegram blockchain very soon. Well, we also have it on Arweave. Yeah. Oh yeah, yeah, yeah. That's a great question. That's a great. Okay, so for you, so the question SEO, but we have a website called Sign Scan. Okay, it's loading, but basically you're able to. It's like EtherScan. You're able to look at all the attestations and all the schemas up here, and you can even create your own attestations and schemas using like this UI here. So, but I didn't get to the Solana part. Could you repeat that? Oh yeah, yeah, yeah. We don't have it live yet, but currently on EVM, you can totally. Anything? Any other questions that you want to get recorded? Yes. The meta URL. Oh, meta URL. Yes. I'm not okay. I had it deployed, but I forgot where I deployed it. I think it's on base or something, base Apolia. But you can deploy. Oh, so the question is, I'd repeat it. If we have a working example of MetRL and I answer, I forgot where I deployed it, but you can easily deploy it. It won't count. All right, time's up. Thanks everyone for coming. Thank you for the photographer. And see you guys at the booth. Have fun programming.